Hello class, welcome to lesson 7-2, which is all about dividing monomials. We can find, by the end of this lesson, you should be able to find the quotient of two monomials, and you should be able to simplify expressions containing negative and zero exponents. So yesterday we talked a lot about power to a power, product of powers. Today we're going to talk about the quotient. So some examples. If I were to have a variable, in this case c to the 11th power divided by c to the 8th power. Instead, yesterday when we were multiplying, we added them together. Today when we are dividing, we subtract. So we take the top number and subtract the bottom number from it. So c to the 11th power divided by c to the 8th power is c to the 3rd power, because you do 11 minus 8. Same thing over here, r to the 5th power divided by r to the 2nd power equals r to the 3rd power. So we did 5 minus 2. So let's look at our couple examples. We have x to the 3rd times y to the 4th divided by x to the 2nd divided by y. So if it helps you out, you can rewrite it where you just have the same variables together, okay? That sometimes helps people if you are struggling with figuring out how to simplify that many at once. So then I look, okay, I have x to the 3rd times x, or divided by x to the 2nd. So I'm going to do 3 minus 2. So I have x to the 1st power, or just x. And then I have y to the 4th minus, remember, if there's a variable with no number, that's the same as having a 1. So y to the 4th minus y to the 1st, which is y to the 3rd. And these are being multiplied together. So I can rewrite it as x times y to the 3rd. And I have my final answer. Going over to the right-hand side, we can separate this. We have the variable k. And I look and I see that's going to be k to the 2nd. Then I have m to the 10th divided by m to the 3rd. So I do 10 minus 3. That becomes m to the 7th times, and then I have p divided by p. So that's p to the 1st minus p to the, or minus 1. So 1 minus 1, that's going to be p to the 0 power, which later on we're going to talk about how that becomes 1. Just like when we have like 3 divided by 3, 3 goes into itself one time. When we have p divided by p, that's the same thing. It goes into itself once. So that just becomes a whole number times 1, but we don't typically write times 1, so our final answer ends up being k squared times m to the 7th power. And if you wrote it like this, that is totally fine. Go ahead and try to simplify this expression on your own. Hopefully you decided your final answer was a squared times b to the 7th. Let's move on. What if we have power of a quotient? So I take the fraction 3/5 and I want to say 3/5 to the 4th power. That's the same thing as applying that power to both the numerator and the denominator. So you would take 3 to the 4th power divided by 5 to the 4th power. Whenever you have whole numbers, I'm going to suggest you actually multiply those out and figure out what those numbers are. 3 to the 4th power, so we'd have 81 over a number. If we continue on, we have r divided by t to the 5th. That becomes r to the 5th divided by t to the 5th. And you can't simplify that any farther because r and t are two different variables, okay? So that is as simplified of an answer as you can get. So let's practice a few of those. If we look at the very first one, this becomes something where we have to apply our powers. So 3 to the 3rd divide, I'm going to draw in my division bar. And then we have x, a power to a power, right? So power to power, that means we're going to multiply 4 times 3. So x to the 12th and 4 to the 3rd. Like I was just saying, if you have a constant number to a power, I want you to simplify that. So we're going to have 27 x to the 12th divided by 64. And that fraction is as reduced down as it can be because no number goes into both 27 and 64. So that's going to be my final answer there. For 2b, again, I have to distribute this too. So 5 squared becomes 25. X to the 5th squared, that becomes x, and then 5 times 2, because it's power to power. Then I have to apply that 2 to my y, so y squared divided by, don't forget to square your bottom. So 6 squared is 36. Again, there's no numbers that go into both 25 and 36, so I'm done with that problem. Moving on to 2c, I have a squared again. I have to apply it. So 2 squared gives me 4. Y squared squared is y to the 4th, 2 times 2. Then I have 3 squared, which is 9. Z to the 3rd squared becomes z to the 6th, because power to power, remember from yesterday, you multiply that number. And our last one, we have a cubed, remember 3rd power, another word to say that is cubed. So I have 4 cubed, which we already said is 64. I have x cubed, so x to the 3 times 3 is 9, 9th power. Then I have 5 cubed, which is 125. Y to the 4 times 3 is 12. Okay? If you need to write more work than what I'm showing you right now, go for it. That is awesome. Like, there's no problem with that, okay? Why don't you go ahead and try to simplify this one on your own? Hopefully, for your answer, you got 27 m to the 9th times n to the 6th divided by 64 times p to the 15th times q cubed. Okay, so we've talked about the quotient property. We've talked about the power property with quotients. Now let's talk about the zero exponent property. Anytime you have a number to the 0 power, it automatically equals 1. That is something I need you to memorize. I need you to remember anything to the 0 power is 1. And if you plug it into your calculator, so if you were to type in 15, use your caret key, 0, it's going to tell you that equals 1. I promise, if you want to try it right now, go for it. And then we have a fraction to the 0 power. Even though it's a fraction, it still equals 1. Again, a fraction with no variables but numbers to the 0 power still equals 1. So let's look at what that would look like. If we want to simplify an expression that has a variable to the 0 power, again, I'm going to just help organize this a bit. I'm going to put my b's together, my c's together, and then I have d to the 0 power, but there's no d in the bottom, so I'm going to put that over 1. So b to the 4th divided by b to the 2nd becomes b to the 2nd times c to the 2nd divided by c becomes just c, because it's a 2 minus 1. 2 minus 1, this was 4 minus 2. D to the 0 power, anything to the 0 power is just the number 1. So our answer is b squared c. Now I have an expression inside parentheses, and the whole thing is raised to the 0 power. This is when those of you who hate long problems should be rejoicing, because as soon as you see that 0 power, that's all you have to write. You don't have to try to simplify that. When you simplify it, this should be your answer. You don't have to show anything else. If you see 0 power, just write 1. Okay? Go ahead and try this one on your own. Hopefully you saw that this was to the 0 power, so you said that it had to equal 1. Go ahead and simplify this next one. Hopefully this one you determined the simplified answer would be k squared, or k to the second power. If you have questions on those, be sure to ask. Okay, now let's talk about what negative exponents mean, okay? Negative exponents, something for you guys to realize, if we have 2 to the negative 4th power, like we do right here, that is the same as putting it in the denominator, okay? So 2 to the negative 4th is the same as 1 over 2 to the 4th. So if I ask you to rewrite 2 to the negative 4th with positive exponents, this is the answer I would ask for. If I asked you to simplify it completely, I would expect you to write 1 over 16. You'd simplify that 2 to the 4th power. Okay, so if the 2 to the negative, or if the negative exponent is on the top of your fraction, it flips to the bottom. If your negative exponent is on the bottom of the fraction already when you start, then that moves to the top of your denominator. Okay? So the negative just means it needs to move positions within your fraction. Okay? So let's look at what some of that would look like. So here I have v to the negative 3rd power. So I know in order to make that negative 3 go away and just be a positive 3, I have to move that to the denominator because it's currently in the numerator. I don't have any other v's, so I'm going to leave that. And then I have w over w times, I have an x squared in the numerator, and then I have y to the negative 6th power in the denominator. So I know I have to move that to my numerator in order to make it positive, and that's the only y value I have. So now my last step is to write these as a single fraction again with no negative exponents. So my v is going to be on the bottom. W divided by w is just a 1, so that kind of just goes away. My x squared is going to be on top. And I have a y to the 6th on top as well. So I'm actually going to move that over to center it a little bit. So this would be my final answer for that first problem. Now let's take a look over at the center problem here, part B. We have 32a to the negative 8th times b to the 3rd times c to the negative 4th. Divided by 4 times a to the 3rd, b to the 5th, c to the negative 2nd. So this time, we're going to start with our whole number. We have 32 divided by 4 times, I have an a to the 3rd here, and I have an a to the negative 8th on the bottom. So I'm going to move that down to the bottom. I have a b to the 3rd, b to the 5th. Both of those are positive, so they stay where they are. And then my c exponents are both negative, so I'm going to flip where they are. My negative 2 goes to the top, and my negative 4 goes to the bottom. Now I just go through and I simplify these. So 32 divided by 4 gives me 8. It's like an 8 over 1. And then I have 1 over 8, a to the 3rd times a to the 8th. Remember from yesterday, when you have the same base and you're multiplying, you add your exponents, so that becomes a to the 11th. And then b to the 3rd over b to the 5th. If I subtract those, 3 minus 5 gives me a negative 2. Okay? What you need to focus on with these is wherever your bigger exponent is where your variable is going to stay. So I have b to the 5th is my bigger exponent, so I see that's on the bottom. My answer is going to be on the bottom. And I have to figure out how far away are those two numbers, and they are 2 away from each other. So that's going to go on the bottom there. 1 over b squared. And then same with c. I have my bigger c value, or c exponent, in my denominator. So I know my answer is going to remain down there. and they are 2 away from each other. There's going to be nothing left on top there. So then what I have to do is I have 8 times 1 times 1 times 1 on the top. Then I have a to the 11th, b to the 2nd, and c to the 2nd. That ends up being my final answer. Okay, so that was quite a bit more work than that first one. But as you practice them more and more, they get a little faster, okay? So now let's take a look at our last one. We have 5j to the negative 3rd times k to the 2nd times m to the negative 6th divided by 25k to the negative 4th m to the negative 2nd. So again, I'm going to start by writing my whole numbers. I have 5 over 25. For j, I only have j to the negative 3rd, and it's in the numerator. So to make it positive, I'm going to move that to the denominator. I have k to the 2nd and a k to the negative 4th. So I have to move that k to the negative 4th. So that's going to move it to the numerator. Then I have m to the negative 6th. That's going to move to the denominator to become positive. And m to the negative 2nd, that has to move to the numerator in order to become positive. So now I look, 5 over 25 is the same as 1/5 times 1 over j to the 3rd times k to the 6th, because I'm going to add those powers like I learned yesterday. And then m is going to stay wherever m has a greater exponent, which is the denominator. And those are 4 away from each other. 2 and 6 are 4 spaces away from each other. So I'm going to leave it just like that for now. And I'm going to write my final answer. So if I have, in my numerator, I only see a k to the 6th because everything else is a 1. Then I'm going to have 5j to the 3rd, m to the 4th. And that is my final simplified answer. All right, go ahead and try this one on your own. Hopefully you said the answer was b to the 3rd times c to the 5th divided by a squared. If not, go ahead and try this one as well. Hopefully you ended up saying that the answer was 4 times x times y to the 6th divided by z to the 3rd. And we have our last example here. We're going to talk about the order of magnitude of the mass of Earth is about 10 to the 27th. The order of magnitude of the Milky Way galaxy is about 10 to the 44th. How many orders of magnitude as big is the Milky Way galaxy as Earth? So something to know about what an order of magnitude is. An order of magnitude is the basically the powers of 10, however many powers of 10 it is. So the order of magnitude of the mass of Earth is about 10 to the 27th. So if I ask you what the order was for the Earth, it'd be 27. Okay? How many orders would the Milky Way be? 44. So I want to find, we want to know how many orders of magnitude as big is the Milky Way as Earth. So we're going to take our Milky Way, and that's 10 to the 44th. We're going to divide it by our smaller Earth galaxy, or Earth, to try to figure out how many times bigger the Milky Way is. So we have the same base, and we have a power and a power. So this is the same as saying 10 to the 17th, because we do 44 minus 27. So to answer the question, how many orders of magnitude as big, we would say 17 is our answer. It is 17 times bigger in magnitude than the Earth. That is the last question I have in this video for today. If you have any questions at all, please be sure to ask for some help, whether it's from me, a friend, another teacher. Please be sure to make sure you understand this. Have a great day.